Hello, everybody. My name is Christian Canales, and we are going to go through question number 3 of chapter 6 homework. Key variation problem 6.8. So, give me a second. Let me get everything just set up. Okay, so part A. An air track glider mass. Wait, no. Air track glider mass 0.15 kg is attached to the end of a horizontal air track with a spring force constant 45 newtons per meter. Initially, the spring is unstretched and the glider is moving at 1.25 meters per second to the right. For the maximum distance, okay. For initial energy, we know that the glider mass only has kinetic energy 1/2 mv squared because it's unstretched, and we know that would be converted into this. So what we're gonna do is just set these equal to solve, which would equal to this. So find D, we're gonna just rearrange it to that. And then we're going to use all the numbers from the problem. And then this. We're going to plug all of this into here, that equation there. And then we should come out with about 7.22 centimeters. Pretty simple. Just use your knowledge of these two equations and set them equal to each other so you can find the distance. And yeah, and then these are just given to us. Yeah, these are just given to us. So yeah, that's that. That's part A. We are going to go to part B now. So that's going to find the maximum distance that the glider moves to the right if air is turned off so that there's kinetic friction with the coefficient 0.320. Okay, that's part B. So I'm going to write this down. Friction goes mu kmgd. That's the work done by friction over distance. Okay, we're just going to do what we did before. But do this. Because this is the initial KE. I'll just do that. This is the max stretch. This is energy loss of friction. Okay. Plug it in the same that we had got earlier. We're just gonna plug in all the same numbers. And now we know that mu k equals 0.320 because that's the coefficient. And then when you plug that in, it should equal out to 6.25 centimeters. That's your answer for question part B. Okay. For part C, we're doing air track glider with friction. A mass M is on a fictional track moving left with speed v. The spring constant k is initially unstretched, then compresses by distance d. Okay. So work energy theorem. Is this the weight of the spring plus friction? Okay. So we put that together. You put down this equation right here. Negative 1/2 kd squared plus negative These are all just things we've done before. And then you're going to get negative 1 over 2 mv squared equals kd squared minus this. And then you're just going to solve it. And make it we're just going to solve for mu. This is going to equal to we're just getting this one by itself. And then that was what it would look like. That's part C. So on the part D, the key idea of this one is that the work done by gravity between 2 points equals the negative change in gravitational potential energy. And we can show that with W grav equals UI minus UF. That's the F. So we know that points A and C are the same height and same angle. This one, right? So potential energies are equal. So we know this. So we could just write out this equation. Therefore, WAB equals, and we know that the bob goes from a higher point to the bottom, so it'll be positive. And we know that the bob goes from a higher goes from bottom to a higher point. So that will be negative 0.487 joules. Okay, that was for D and, oh my bad, that was for D and E. So this is D because it goes from top to bottom, right? And then, no, yeah, it goes from top to bottom. And then B goes from bottom to top, but since it's reversed. Since these are both the same, like, angle, it'll be just the reversal of that. Okay, now on to F. It's going to be the same thing, so we're going to use this equation. UA equals UC, WAC equals 0. That was not too hard, since it's equal. Okay, part G, just a pendulum. So it'll be MGL plus 1 divided cosines equals 1 over 2 MV squared. We're just going to make those equal to each other. Which one gets you? V equals square root of 2GL 1 minus cosines theta. Okay, that's it. Pretty much we're just doing at maximum angle theta. The energy is gravitational potential, and at the bottom is all kinetic. The spiral drops by this equation here. Right? So that's where we got that. So we just gotta set mg change in y, which is this, equal to this, and then we can solve for that. That's too hard. That's pretty much the third problem there. Yep. So nothing too crazy today, but it's something, So thanks for watching, and yeah.